everybody. My name is Massimo Colombo, Metis Sales Manager. I will give you a brief introduction of our company before listening to our technical expert, Jürgen von Kanen, that will do the technical presentation. So, a few words about our company. Metis is, of course, a scanner manufacturer, Italian company based in Rome. Our headquarters is in Rome, and also our demo facility is in Rome, where we are showing all our current scanner. And our production plant is in Tuscany. Well, of course, I wanted to thank our partner, AVA and Roland, who have arranged this webinar, and all the participants to the webinar. And a special thanks to the Metis client that are participating. I've got many emails saying that they were participating, so thanks very much for joining this webinar. Okay, now to continue. So I will not bore you with all the story of Metis because it's a long story, but there are a couple of points which are very important to us, because in Metis we continue a family tradition of industrial designer that started almost a century ago. And the founder of the company, who started his career in '65, brought a lot of his fantastic experience in the photographic scientific application and remote sensing and satellite imagery. And he was consulting for 25 years with European Space Agency. So all this technology has been brought in Metis, and the Metis R&D team has developed that. So you will see from the timeline while I'm talking all the type of system that we have been manufacturing. So Metis was created in late 80s, and for 15 years we have been developing system and giving solution to the cultural heritage field for any type of archive, library, and museum that any needs to scan their patrimony. They were using our scanning. So we can count actually on big names like the Vatican Library, the Library of Congress, and more than 200 institutes all around the world. So we have been manufacturing all these systems through the time, and actually in 2009 we decided to enter also the market of the industry. So we have to redesign the light, because that was crucial for us to have a completely different light from the application in the cultural heritage. So we made a patent, which is the DCS Synchro Light. And so in 2010 we started with this complete new redesigned system entering the market. And actually in a few years we got really the best possible client in all the industry like ceramic, industry like wallpaper, wood panel, flooring, fine art. That was also thanks to our partner, that because apart from the demo facility that we have in Rome, we can also count on demo facility in USA, thanks to CGS, which is our partner there. We can count on 2 demo facilities in China, thanks to our partner Cytoprint in Shanghai and Foshan. And we can also count on a demo facility in Tokyo, thanks to Toyotech, which is our partner in Japan. So we have been continuing developing new system and new application. We moved in 2016 to a new factory, as I said before, and we had a new sensor on the DRS family 2018. So, but the technological milestone for Metis was between 2013 and 2014. In 2013, Metis started as the first scanning manufacturer to use the 3D photometric stereo technique, which is a technique that allows accurate 3D data for engraving and embossing application. And as you will hear from Jürgen, that is applied in the industry using directly our files to engrave, or to use for AVA, directly the 3D for AVA, or for Roland to print out the 3D, the texture. And for many years, Metis has been the sole scanner manufacturer to use this master technique. Then in 2014, very important, we made the Metis SuperScan PM3D. We launched it in the market. And actually, this is patented protected because it's a very, very special technology based on an innovative design adopting for the first time a telecentric lens instead of the standard optic. The PM3D provides unique performance that really doesn't fear any comparison in the market. To have a quick look to the scanner that we offer to the core application industry today, again, the Metis SuperScan, patented protected, the DRS 2020 DCS, which is the most sold in the DRS family to our client base, and the DRS 1520, which is adopting the same type of technology of the DRS 2020, it's just a different size, a smaller size. Last but not least, the Surf 3D, which is our entry level, which is very fast and easy to use, completely automated, good color and 3D data, still using the photometric stereo, and can be used to color profile a printer. Thank you very much for your attention, and now I pass the word to Jürgen. Thank you.
Hello everybody, and thank you Massimo for this short introduction. Massimo asked me before I start the presentation for the webinar to tell a little bit about myself, my past, and what I do today, for example, as senior technical specialist from Metis Systems in Italy. I will gladly do that. For this, I will share my screen with you now. So, my name is Jürgen von Kannen. I'm a technical designer. Design and technology always fascinated me, and I'm always looking for innovation in design processes. That has shaped me and my way of working. I want to tell a little bit, very compressed, I swear in under 3 minutes, about my past. I have 35 years of experience in 3D modeling and also in advanced 2D image processing. I was the founder of the first computer graphics studio in Germany, where I specialized me in high-end composings for technical products and process visualization. My studio got a lot of appreciation in publications like Novum, Computer Art Fascination, Reader's Digest, and so on. In 2008, the owners of Ungricht, world leader in industrial engraving, asked me for help in redesigning their design studio and optimizing their 3D engraving data. In 2009, Ungricht was, with my help, the first engraving company worldwide with a complete 2D, 3D design creation workflow. Between 2012 and 2014, I was looking for advanced 2D, 3D scanning technologies for this company. During this time, we had all available scanners on the market from all manufacturers, including today's competitors of Metis, to compare the technologies with each other. So I found the scanners from Metis Systems in 2013. In the same year, we installed the first Metis DRS 2000 system at Ungricht. In 2014, we installed the second scanning system, the flagship of Metis, the PM3D. It was the first installation of this scanner worldwide in the decor industry. Between 2013 and 2014, I was involved in this development of this still unique scanner for decor application. Today, I'm a consultant for IT and especially therefore image processing technologies. I give also support in design creation, especially technical design. And today, the innovation management is also a part of my portfolio. In the field of 2D, 3D scanning, I'm working exclusive for Metis Systems in Italy. So I think the audience now understand why I'm doing what I do today, and that it is a great motivation for me to help customers worldwide with their processes and their problems and to find appropriate solutions for them. We don't have much time here, so I'm going to cut the chase and start my presentation for today's webinar. I would like to introduce you today to the part of a workflow within a decor reproduction that deals with the scanning and preparation of the data required for this. In this case, we are talking about printing and embossing data for a 3D prototyping printed on a Roland DG multipass printer. For our test production, we use a typical material for decor application, some wood planks. To control the scanner, we use the Metis scan director software. After the material has been prepared, sometimes the planks are bent and this mistake must be corrected. The original is carefully placed on the scanning table. For your information, this industrial scanner is able to scan originals up to a weight of 200 kilograms or 440 lips. In this case, we acquire the color and the 3D depths, and we do it with the greatest scanner in our portfolio, the Metis PM3D. You see here the interface of the Metis scan director. In the Metis scan director, we have the possibility to control the scanner hardware. Here we crop where we want to scan, make 600 ppi, it's enough for digital printing, and say make a super scan. Now we see the calibration. It's a 4-pass super scan. And now you see the scanner hardware. The bridge here with the head, for your information, has a weight of around about 500 kilograms. In this head are 8 lights for soft and for hard lights, so we can adjust the casting of the shadows to get any appearance we want to get. Here we see a little zoom on the original material, and now the scanner head is going on here. So, before we talk about optimizing scan data with our software Metis Light Inspector, I want to explain the different uses of the selected scan data. On the left side we see 2 colored versions of our material, one with a flat appearance and one with a more 3D appearance. We can discuss later why we need sometimes a more flat and sometimes a more 3D version. On the right side you see 2 versions of a 3D depth map, a grayscale and a black and white version. We need this depth map files for embossing. We can discuss later why we need sometimes a softer and sometimes a harder version, or why we split them into slices. In case of producing only the color, we can use in all processes the colored version with more 3D appearance. The technical separation for colorways can be very different for various processes. Since we usually have no problems with mismatching in digital printing, we can use both versions of the color, with a more flat or with a more 3D appearance. This is a matter of taste. In the traditional laser etching process and in digital printing single pass with digital embossing, we usually use the black and white version of the depth map. In traditional embossing applications, for example engraving with laser direct, and in multipass printing applications, we usually use the grayscale version of the 3D depth map. Here we get the best results for 100% reproduction of a surface. Because of mismatching in this process, we mostly use a slightly flatter version for the color to avoid duplication effects caused by the printed shadows and the shadows created by embossing. In this case, we use the color and the depth data to produce a 3D prototyping on a Roland multipass printer. Now we know the different uses of selected scan data, and so we will start with optimizing the scan data. For this, the Metis Light Inspector starts automatically direct after scanning. This is now the interface of the Metis Light Inspector. The software starts automatically after scanning. Here we see two planks of the material. We see we have now an empty custom setting list here. We have no settings. It's what we see is a flat light version of the color. If we go inside, we have no shadow and highlights. So I make a version color flat. This is the first version. Then I make a little bit a version, a moderate version from top light that we can use also as a with a more 3D appearance. I will push a little bit the shadows here, and I do that. We can control it very good here. So I make here a color 3D appearance. Then I go to recalculate the depth data. We have now the depth data here. This is a grayscale version. We can use it for the laser direct engraving and multipass application. 3D depths. Okay, and then for the application single pass digital, we make it more flat and more hard. That is, I think, a little bit. In this case, we make a 1-bit version. We must not do only a 1-bit version in single pass. We can also do a 8-bit, because single pass can also use more than 1-bit information, but that we can discuss later. So I make this black-white 3D depths. Okay, now I have here a setting list with black, white, standard 3D depths, this color 3D appearance here, and a flat color. So what we also can do is we can evaluate this data inside of a real-time 3D window. Now we see this. I change this here a little bit. If we want to show only the 3D depths, then I change a little bit here this parameters. So this is the information you normally get from the grayscale 3D depth map. We see we have horizontal and also very fine vertical structures here. Very good. We can push that a little bit. I do that. Now we have a little bit more of these structures, because in a normal process it will not be 0.8 millimeters depth. It's more 300 microns, and then it is helpful if we have some structures here. So if I go back we got a little bit correction here, and I save it one time more in the standard 3D devs. I override it so that I have this information. The same we can do to evaluate this with the embossing data for single pass. We go also back in this window, and we see if we make a lighting here, we got more other information here. It's very fine, I know that. Go inside 100%. In combination of this, we have a little bit the feeling for this kind of embossing. It's very hard. There are possibilities to make it smoother. We can do that. I smooth it here, the information. So I have to evaluate the data for the single pass. I have now a good feeling what I got if I make a digital embossing with this data. The data we put it inside of the process in hard, and we know they can make it not so hard. It comes more like this. And so for many design studios, it is a fixed procedure not to consider the raw data or the layouted image composition only on a planar surface. So we see the possibilities of our raw scan data, or of a complete new, in this case, all-over decor. With specialized software, you can see your raw data, for example, under different light situations. After optimizing, the data is passed on to the post-processing. Here retouching is carried out, among other things, and layouts, technical separations and colorways are created. AVA or Photoshop is usually used. A benefit with AVA is that color and embossing data can be processed simultaneously. This is also important in our test production, as it is an embossed in register production. So let us hear how you can do this in AVA.